In this workflow video about the detailed design and documentation phase, I'll provide an overview of the overall goal of this phase and provide insights on what we're looking for in this phase. I'll take a look at model detailing and which kind of simulations and simulation programs we can implement, and look at some of the conclusions and how the knowledge builds from this stage. Once the final design is aligned upon, the team can now prepare for construction by creating a fully articulated design and building information model. So the key in this phase is going from a very generic BIM model and using the insights we got in the previous phase to quickly go in and turn this model into a product model, still using analysis, modeling and visual models for looking at the exact geometry of a building. Now focusing on materials, choosing the specific products and manufacturers we want to implement, and look a lot more into integrating active systems and looking at thermal comfort, simulation of total energy consumption using more specialized simulations like VIP Energy, the IES, or here in Denmark the BE10, for doing really the validation of the final energy demand of our building. With inside Revit, we can now go in and begin, based on the knowledge derived in the previous phase, to turn this very generic model into a more complex building information modeling with the right layers and constructions, materials, etc. And turn it into a model where we can now start to model things like MEP, construction models, etc. for doing coordination before doing the actual construction. And of course, keeping really the connection between the very generic BIM model and the drafting that we do, looking at how these constructions are assembled for reducing thermal bridges, looking at airtightness and things like that. Here we can also really still use tools, conceptual tools like Ecotect for looking at heating and cooling loads, reverberation times, that is really overseen things within inside Ecotect that we're now able to actually go in and begin to work with our rooms, looking at the actual material properties in relation to reverberation times. Use tools still here like 3ds Max Design for validating and working with the actual materials in combination for visual comfort, using radiance and DASIM or other more specific simulations that we will need for really validating the designs in here. And again, bringing this in at a later stage to really be able to work and validate that our design is performing the right way. Let's take a closer look into modeling and simulation in this phase. So as in the design development, we are now working with more complex models, and we are working with the constructability and integration of active systems and doing full energy analysis to validate the design performance of our building. But the key here, let's take a look into Revit, is that we can now, because we're working in this process, we can really start going in and instead of having a very generic wall here, to build in the layers that we want to build into our model here. If we just go here, we turn on the section box, and just to see that we can have a lot more efficient BIM process and design process, just starting out in the design development having a very generic model, and then when we have aligned on constructions, heights and main geometry in a model, we can quickly turn this into a product model, choosing the real manufacturers and products that we want to build into this building. And if we take a look here on this project here that we actually built on the Danish Technological Institute, which is this test building called the Energy Flex House, where we built a very flexible building where we integrated multiple active systems to use this house as a test house for different types of active system, ventilation systems, solar panels, stuff like that. So this is really kind of the way that a really detailed model would look like. And of course, this is where we're doing the final drafting, keeping the relations between 3D model and the detailing is really the key here, and then we can really create some really validated models and quickly move into this phase the right way. With inside this phase, we can still of course use really simple and conceptual tools like Ecotect for now looking at things like shadows in relation to the more complex geometry that we have in our building. So just to visualize this, that now we do have really the thickness of the walls, and we have the right windows, stuff like that, and that means a great deal for how the light will penetrate our building. In this case here, we can really still use conceptual tools like Ecotect, and we can also do daylight simulation for getting kind of a sense of the real product that we build into the system here. But again, here we want to move into more details using 3ds Max Design that is really great, not only looking at visual comfort for daylighting, where we can also simulate things like artificial lighting more efficient, and really use this program for validating the final visual comfort in our building. At this stage as well, use tools like DaySim in connection with Ecotect. But here we want to move in, and we want to move into using some more detailed programs like VIP Energy. That's really a cool product from Sweden that we can use for measuring the whole energy consumption and energy needs of our building. Tools like the IES or the BE10 that we're using here in Denmark. Also with inside Revit in the 2013 edition, we are actually working with physical materials, which means that we do have now, we can add in a physical element to our building, and then we can actually push the physical elements from this material into our design. So it will actually help us to understand basic thermal behaviors, mechanical properties, etc. that we can use for quickly getting a sense of the performance of the construction that we build into the project. And again here, now we've figured out where to place things like solar panels, ventilation system has been integrated and stuff like that. So looking at airflows, using all the things that we did in the analysis phase of the project, using that as a foundation for quickly moving in, creating some very validated design is also a key in sustainable design development. Let's look at the conclusions and next steps. Now we really, based on the analysis process and the iteration that we did, we created an optimal foundation for our design and moved it in and made the transformation to a real product model, did the drafting, implemented active systems, looking at airflows, and based on the simulations previously, we now have the optimal foundation for getting validated in more specific national standards for energy simulations and energy calculation in this phase. So this phase is a lot more about validation of things like acoustic. It's more about validating the program in really the final product that we're looking for. For this tutorial, didn't integrate and show these more detailed programs because they're really national standards a lot of times, like Energy Plus in the US, and here in Denmark the BE10. So to really merge that all in here. But I think that the key here is that because we are working in a very structured process, and because we have that solid foundation, we can now have a lot more smooth process actually making this building, and we have now ensured that we have the right comfort and we have the right energy consumption of the building that we're planning. Thank you.